All right, so this is the video for scenario 2 for the test review. And just like in part 1, where I focused on what was in the Google form as opposed to the questions below, I'm going to do the same thing here. Now, there is a very close relationship, but I'm going to focus on what's in the Google form. So it says success in hunting varies greatly among species of animals. Lions who hunt singly are rarely successful in more than 10% of their hunts. Wild African dogs who hunt in packs are among the most efficient of all hunters, succeeding at a rate at over 90% of the time. That's kind of interesting. Lions are only successful 10% of the time. They hunt by themselves, but the dogs that hunt in packs are successful 90% of the time. Pretty amazing. In the early 1960s, researcher Jane Goodall discovered that chimpanzees were not solely vegetarian in their diets as previously had been thought. This discovery spurred a tremendous amount of primate research. Some of the latest primatology research has been done on chimpanzees to find out if larger hunting parties increase the chances of a successful hunt. The results of one such research project are summarized in the table for the number of chimpanzees in a hunting party versus the number versus the percentage of successful hunts. So we have the number of chimpanzees in the hunting party, and we have the percent of success. And please notice right here there is no 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 16. And it says, first off, it says, find the sample regression line for determining how the number of chimpanzees in a hunting party affects the success success of the hunt. Well, I'm going to say that we need to probably start off by doing this. Let's go ahead and go to our calculator, and hopefully you can see that. It's kind of blurry. Not sure what's going on. See if that's a little better. Still having a little bit of problem. So see, yeah, that's pretty good. That's about as good as we're going to get. So I went to stat edit and I entered all that data. And these data, the number of chimps is my X value. We're going to see if that can predict Y, the success rate. And please remember, there is no 11. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Skip 11, 12, 13, 14, 15, and 16. And then I've input all the data in there, and it says, find the sample regression line. And on the Google form, it says, identify the numerical value of the y-intercept. Well, once I've input the data in here, we're going to go stat, press the stat button, arrow over the word test, and we're going to scroll all the way down to letter F. My X list is L1, my Y list is L2. Make sure we have the not equal because we're working with regression. And this is super important. Right here, you better be pressing alpha trace, then enter. Okay? And if you do that, you should get all this information. Now, if you don't see all that, we need to go back and do something else. So let's do that real quickly for some of those you might have a trouble. Go press mode. The mode button is right here. And drop all the way down to stat diagnostics. Arrow over to it's on and press enter. Once you've done that, you should be good to go. We still have everything in stat edit. I'm going to go ahead and quit out of that and rerun that test. Stat test. Drop down to letter F. And make sure not equal is highlighted. When we get to here, press alpha, the alpha button, followed by the trace button, and enter. And now we get all of our information. Now this is always a little bit weird, but the A, the 22.7, happens to be the numerical value of our y-intercept. So 22.7. Identify our slope. Our slope is the B, 3.98. And I know you may have trouble remembering that, but slope is always next to the x. So the b is next to the x. So we're going to write 3.98. Then it asks for us to write the regression equation. So we're going to write y equals 22.7 plus 3.98x. And by the way, this really should have a hat on it, but you don't have a way to do that. So if you type this into the computer for the Google form, that'll be great. The next thing it says is identify the numerical value of the coefficient of determination. If I scroll down, r squared is that. So r squared equals 0.9196. R squared is 0.9196. That's a very high relationship. And I'm going to take a moment and show you something, and then I'll come back to this. I'm going to show you how good of a relationship this is. If I were to graph this thing, if I just second stat plot L1, L2, oops, zoom 9, we see we have a pretty nice pattern there, pretty linear. All right. So back to stat test, letter F, everywhere where we were, alpha trace. And then it says, give the numerical value of the correlation coefficient. That's what the next thing was in the Google form. It says, give the numerical value of the correlation coefficient, which in this case is just R, and R equals 0.9589. And really all we're looking for is the 0.9589. Then it says, what is the likelihood that a party of 11 chimpanzees will have a successful hunt? Well, to do that, I'm going to need my initial equation. And my initial equation was the y equals 22.7 plus 3.98 times, we're going to just plug in 11. Let's see what happens. So 22.7 plus 3.98 times 11. And we go, gosh, that's pretty successful. Okay, we would expect them to be successful 66.48. And this would be the answer that we type into the Google form right there, the 66.48. Now the question is, does that really make sense? So if I were to look back at the numbers, and I'm going to need to pause this for just a moment. Pausing. Okay, so the question is, does that value that we got, that's the value that we just calculated, a 66.48, seem reasonable? Well, when we were at 9, we were at 65, we were at 12 at 75. So 66 is in between that group. So it might be reasonable. So it seems like we probably did so. Probably did a good job. The next thing it says is, what is the residual for a hunting party of size 8? Well, first off, we need to remember that a residual equals the observed minus the expected. So what was the observed? Because that's easy. We can just pull that off the table. Well, at 8, we observed 62. But the expected, it takes a little more time. We have to do a little bit more work. We're going to have to go 22.7 plus 3.98 times 8. So 22.7 plus 3.98 times 8. And we get 54.54. So this is what they would have predicted. This is what we predicted, but this is what actually happened. So 62 minus that value, and our residual equals 7.46. So 7.46 is the residual. We were off by that amount. If this number had been bigger than this, it would have been negative. And it's okay to have a negative residual. Residuals can be either positive or negative. just make sure that you're doing observed minus expected. In other words, what actually happened minus what we calculated from the predicted line. Okay. Number 27. It says, what is the symbol for the null hypothesis? Well, all year long, we've been very consistent. The symbol will always be an equal sign. Okay, it will always be an equal sign. Number 28, what is the symbol for the alternative? Well, when we're working with slope, all right, this is not true for all regression or for all hypothesis tests, but when we're working for slope, we're looking for a not equal. All right, so any regression equation that we're going to do in this class will always be not equal. Then it says, what is the numerical value for the alternative hypothesis? Well, turns out beta 1 and beta 1, this was equal and this is not equal. For slope, it'll always be 0. This is no linear. There is a linear. But the numerical value for the alternative hypothesis and for the null will be 0 all the time. It says, what is the test statistic for the hypothesis test? Well, I need to go back and go stat test, letter F, do the alpha trace. And I get a t statistic of 12.1944. T equals 12.9, oh, excuse me, 12.1944. And the part that I'm boxing in is what you should be typing into the computer. What is the p-value? I see it's to the -8th power. So that's approximately 0. Okay. Technically, if I were really writing it out, I'd have 7 zeros. I'd go 0.1, 2, 3, 4, 5, 6, 7, and then 1, 7, 2, 2, etc. But once we get to 4 zeros, it's approximately 0. And so you could have typed in 0 and that would have been 5. Based on the p-value, what is the correct decision? All right. Well, I really don't care what your alpha is, but let's just say it was 0.05. And I think they told us to use 0.01, but let's just say it's 0.05. Our p-value is 0, that's less. If it's less, we reject. So we reject the null, so that gets rid of the fails. Remember, we reject no linear, we believe there is a linear. So the slope of the line is not equal to 0. Right? We rejected this and we believe the not equal. How many degrees of freedom are there? Well, degrees of freedom are going to be the sample size n minus 2 for regression. Well, this case, our sample size is 15 minus 2 happens to be 13, and we could just type in 13. But the calculator did the work for us. And you're like, wait a second, I thought there were 16. And I'm like, remember, we skipped number 11. That's why there's only 13. The next thing we need to do is calculate a 99% confidence interval. So we need to calculate a t-star value. So second, because remember, it's going to be b plus or minus t star times the standard error. So here we go. Second vars inverse t, 1.99 divided by 2, degrees of freedom, 13. So we're going to end up with a t star that's going to be pretty large, of 3.01. Always make it positive. So 3.0122. And notice this was t star because we're working with a confidence interval. All right. This is not the T statistic, this was T star. Up here they asked for the T statistic. Here we're asking for T star because we're working with a confidence interval. What's the lower bound? Well, I don't know, but the calculator is going to be really nice to me and calculate it. So I'm going to go stat over to test, and I'm going to drop down not to F this time, but to G. And I'm going to put in a confidence level of 0.99. Regression equation. So this is where I'm going to do the alpha trace and press enter and calculate. And I get a lower bound of 2.9969. That's my lower. And an upper bound of 4.9631. And then it asks for the best estimate. The best estimate is your slope, which happens to be measured by B, which in this case is 3.98. All right. So basically our confidence interval looks like this: 2.9969, upper bound 4.9631, and right in the middle is 3.98. Right in the middle is 3.98. If I added these two values together, they would average that. Okay, this is my best estimate, and that is B. Your test is going to be extremely similar to this. I hope you paid careful attention. It'll help you out a whole lot on your test. All right, thank you.